So let's think about in terms of quadratic function. Y is equal to ax squared plus bx plus c. Let's think about in terms of properties of this function. Y is equal to ax squared plus bx plus c. At first, in order to graph a function, we need to convert this graph y is equal to ax squared plus bx plus c into a vertex form. The reason is because we could have just find some values of points of coordinates through this function, but we cannot exactly graph a function since we don't know a minimum or maximum points. So that's why we need a vertex form. And I'm going to talk about it later how to convert into a vertex form. Second property of this graph, it passes through point 0, c. The reason is because for y is equal to ax squared plus bx plus c, we know that if we input a value of the x value to our terms, we're going to get just c. The reason is because even though the a value and the b value, which are constant of x terms, exist, if you input a value of 0, it will going to be a times 0 squared plus b times 0 plus c. And that should be equal to y. But 0 squared, whole this thing will turn into 0, and then all of these things will also going to turn into 0. And we get c value is equal to y, which is exactly the same thing as we have saw right over here. So that's why it passes through point 0, c. Let's look at our third property of y is equal to ax squared plus bx plus c. The definition, the third one is kind of a definition that if a value is greater than 0, the graph will go upward, and when the a value is less than 0, the graph will go downward. And we have already proved this kind of thing in the last few videos, and we know that a values are a coefficient of the x squared term, which we can call it as a leading coefficient. And when the a value is greater than 0, which means when the a value is a positive value, the graph will go upwards, such as this thing right over here. And when the a value is less than 0, which means the a value will going to be a negative value, the graph will go downwards, such as this term right over here. And we could have actually seen this before that a value doesn't really affect when it comes to graphing a parabola, but the only thing that it affects is a forming of a parabola when it goes upward, or a downward. At first, let's think about in terms of how to convert this quadratic function y is equal to ax squared plus bx plus c into a vertex form right over here in order to graph it. We only need the x terms for making into perfect square, which means I'll just put a parenthesis of it at negative x squared and then positive 6x, and I will leave negative 5 here, but it still counts as our thing. And if you think about more about this, the first step that we need to do in order to convert this into a vertex form is that at first we need to make a perfect square using this quadratic function. Y is equal to ax squared plus bx plus c. What it means by perfect square is that, let's say x minus 2 squared. This is a main example of perfect square. Perfect square means we are multiplying exactly same terms together for 2 times. And if we extend this one right over here, it will going to be x minus 2 times x minus 2. And this one is just a simple way of writing this. At first, for the example of a ax squared plus bx plus c form, I will give an y is equal to negative x squared plus 6x minus 5. And at first, in order to make into a perfect square, only thing that we need to carry in this form is the x terms in this case. We don't have to care about a constant term. All we have need is a x terms, the term that contains the unknown variable in order to make into a perfect square. We only need the x terms for making into a perfect square, which means I'll just put a parenthesis of it at negative x squared and then positive 6x, and I will leave negative 5 here, but it still counts as our thing. And if you think about more about this, and if you know really about a perfect square, for this term, the constant, which will going to be unknown quantity that I'm pointing out, in order to find it, we have learned a formula for it that we need to take half of a x terms, which in this case will going to be 6, and then square it. And this will going to be our formula for it. And if you actually calculate it, it will going to be 2 and a 6. We're going to cancel less than 3. And then 2 will going to be positive 9. And we can think about in this way that in order to factor this out, but if you think about it in terms of a coefficient of the x squared term, it is in this case we're going to be negative 1. So we're going to be negative 1. But if the coefficient of the x squared term is not equal to 1, it's hard to factor it out. So all you have to do is divide whole expressions into negative 1, but not a constant. So if you do that, it will going to be negative x squared. Positive divided by negative will going to be negative, and then 6x. The positive 9, and then divided by minus will turn into negative, and then we bring 9. And then, but since we added negative 9, we also need to plus a positive 9. The reason is because if we just add 9 here, it will gonna affect our original function, which will going to be negative 5. And then we need to make this into a 0, which means we don't have to think about it. And if just negative 9 exists, it is way too far away from our answer, which is negative 5. So we also need to add a opposite of it, which will going to be 9, in order to not affect our original function. And then we still bring our negative 5. And then we will get, at first we can just bring our 9 to the outside because we don't really care about it. And we get negative x squared. Only thing that we need to care is x squared minus 6x minus 9. And then if you do that, let's think about it in this way that at first negative 6x, but at first let's remove this negative 9. In order to remove the negative 9, all we have to do is add positive 9, and then we will get negative 6x, and we get positive 9, and that is equal to negative 5 plus 9, which will turn into positive 4. And we can still factor this term out, which will going to be negative x minus 3 times x minus 3 if you know about factoring a lot. And then it will going to be simply x minus 3 squared because we're multiplying the same thing. And we always need to get it's not equal to 0. It should be a positive 4. So we got our vertex form for it. This is our vertex form. And let's think about this way. For the vertex form, the reason why I find it is because two things. We can read this graph and we have learned about it in the last videos. And for actual things, because we want to find a vertex which can be negative or positive, depends on an a value. But the a value in this case is a negative, which means the graph goes downward like this case. So we know a vertex form. And for negative x minus 3 squared plus 4, that should be equal to y. And for the negative 1, the way to find a vertex is find the x value, which turns this whole expression into 0, and the leftover is a y value. Which means for making this whole expression 0, we need to input a value of 3 to the x value, which we're going to get negative 3 comma negative 3 squared plus 4 is equal to y, but since we input our value of 3, we need to make a coordinate 3, comma, And for the y value, if this turns to 0 because 3 minus 3 is 0 and then square is 0, and then we get y is equal to positive 4. We can write it down. And now all you have to do is we find a vertex of 3, 4. And this is the way how we find a vertex. And we just made a practice example before we solve for a real questions.